In this lesson, we're going to do some basic uncertainty reasoning. And by the end of it, you should understand why the total uncertainty is the way it is when you're dealing with sums and differences of different quantities that have their own uncertainty. And you're going to understand why it is we take an average whenever we are working out a measurement. So let's first look at the uncertainty involving sums and differences, and we're going to do a sum. We're going to consider two lines, A with its uncertainty delta A and B with its uncertainty delta B. If we were to take it and put it on a table which consists of their maximum possible values and their minimum possible values, we can see that we have A plus delta A for the maximum of A and A minus delta A, which is the minimum of A. This delta A here just simply represents the uncertainty that we have in that value. Similarly for B. If we was to take these two values of length and add them together, we would see that the maximum values when added together would yield this, and the minimum values when added together would yield this. Notice that at the end of it, they will still give the same answer, the total value itself and the total uncertainty. The only difference between them is the signs that they experience, which is one is positive, one is negative. That means when you're stating your answer for anything that is summing or finding the difference of, all you have to do is just simply find the sum or difference of the quantities being measured, and then you find the total of the uncertainty and you put a plus or minus between them. And this is how you state your uncertainty whenever you're doing total sums and total differences. Alright? So next question is why we do an average whenever we're taking a measurement. And we're going to answer this question by simply looking at two cases. And we're going to assume that all the balls that we're going to show in these two cases are identical. Our goal of the objective is to determine the diameter of one of the ball. So let's say, for instance, we have this case 1. We have one ball, we take one measurement. And case 2, where we have 5 balls lined up touching each other and we take one measurement of these 5. In the first instance, the diameter of one of them is going to be stated as 2.0 plus or minus 0.05 centimeters. And we could understand how we get this if we use a centimeter rule, a 6-inch ruler. And for the second case, case 2, we see that the diameter of one of them is going to be equal to 10 plus or minus 0.05, since it's one measurement that we take, and we're going to divide that by 5. Reason being that these are 5 balls, so we divide by 5, we will get 2. And notice the uncertainty that we get in both of them. The uncertainty for the case of the average, which is what this is here, is much lower than the uncertainty for the case by itself. So we come up with two rules, that if you have the case 1, this case here, x plus or minus delta x is there, and in case 2, x plus or minus delta x divided by n, which is the average, will be much better. So if you have any questions or comments and you have anything that you want to tell me, you can simply leave me a message. Thank you.